Hi, everybody. If you just give me a quick note, can you hear me? You're not going to see much of me. I'm going to go to a PowerPoint presentation. Just looking to see that we're actually live. So if there's any messages to type. Okay, I'm not seeing anything. I saw Reggie's message from Iowa, and not seeing anything else. I'm going to go right into the presentation. So, all right, people are saying they can hear me. I'm going to go ahead and go into the presentation then and share it. And let's make sure all right, let's go to window. And okay, so this is the Mentor Flyer of Record training for collegiate competitions. I'm Steve Lubliner, been around the NAR for a while, been around Tripoli for a while. And this is the VNARCon presentation. And just for the agenda, a little bit about me, what the problem is, some of our objectives, talk about the different competitions, what the mentor requirements are, and how to be a good flyer of record and a good mentor. Again, I'm Steve Lubliner. I'm in Tucson. My sport rocketry background, I am the NARS Safety Committee Chair, Level 3 Certification Committee member, and a NAR member for over 50 years. And professionally, I was an engineer, mechanical engineer with Raytheon and its predecessors, and worked the Tomahawk, the Advanced Cruise Missile, and the Stormbreaker, which was also known as SDB-2. So the reason I wanted to do this competition, uh, there are the collegiate competitions are high power rocketry events. And of course, folks need to be certified to fly high power rockets. The participants typically don't have any experience. They're doing this as a senior project or as a college club activity. It's unlikely in many respects that they even have model rocket experience. They may be launched one or two as a class project, but that's the extent of their participation. The other aspect is a lot of them don't have high power certifications. Some of the foreign country participants don't have a high power certification program. Tripoli does have prefectures. They can do high power certs in some countries, for example, Australia. And we also recognize the Canadian Association of Rocketry. Again, my objectives are the mentors and the flyers of record are the means to address these problems. We're going to identify the characteristics and process of being a good mentor and also of being a good flyer of record. They are somewhat different in their requirements. So I'm just the slideshow. And I'm not going to go through the earlier slides, their presentation. I did talk to them basically, so folks could hear me. Again, we have the agenda. This is about me. And then the problem, and just to emphasize that, is we've got a lot of folks in collegiate competitions who don't have experience. And that's the purpose of the mentors and the flyer of record. And they're supposed to address these problems. The major collegiate competitions, we have the Student Launch Initiative, which is NASA sponsored, that the NAR participates in heavily, and the ESRA Spaceport America Cup that Tripoli sponsors that event, and NAR folks help out. Differences between the events: the SAC event is about twice the size of the larger rockets. The SLI events are typically level 2. The SAC event is mostly level 3. SAC is also an international competition. For 2023, it was approximately 50% international competition. And SLI is US only. SLI targets 4,000 to 6,000 feet. SAC has 10,000 foot and 30,000 foot capabilities. For the Student Launch Initiative, NASA specifies the payload, and they want a functional payload. SAC allows basically a dead weight payload. And finally, the Spaceport America Cup, they allow non-certified EX motors or experimental motors. Okay, again, I'm going to switch back just briefly, just to look to see if people are seeing the slides now. Okay, people are seeing them. Great. Well, I'm here. I'll just look real quick at any Q&A. There's no Q&A. So I'm going to go back to that, and we'll go back. So again, the SLI is a 4-day event, and there is a rain day if needed. It has one flight in Huntsville, Alabama, usually around the second week of April. There's one insurance, and there's 2 documents. They're basically the handbook that NASA provides, and then the students respond with a statement of work. And again, they're limited to L motors, level 2. There's no hybrids, no clustered, and all flights are subsonic. And you'll see the contrast between this and the SAC in a moment. So for 2004, NASA changes up the payloads typically every year. This year, they've got a particularly challenging payload. They're designing an atmospheric independent lander for what they call their STEM knots. And they have 4 STEM knots on board, and they're not allowed to use streamers or parachutes. That's basically the interpretation of atmospheric independent. The landing has to be soft enough for the recovery of human beings. The STEM knot itself for this launch, they're non-living crew members. They can be represented however the team wants to, and it's assumed to have human astronaut survivability. Sounds like an egg loft to me, but that's just an opinion. Minimum payload weight is specified by NASA to be 5 pounds. They specify a maximum landing energy. They do not allow the payload to separate until you're 400 feet above the ground, and they have to have authorization to separate the payload. So NASA for mentors, they, of course, with NASA specifying everything, they do specify what they want for mentors. Person has to be an adult, and they're included as a team member. They support the team throughout the year. They don't have to be associated with the school. Okay. I'm just gonna. Hello. Okay. Thought that may have been someone had a problem, knew how to reach me. They have to be currently certified, level 2 certified, either NAR or AAA. And they have to have had some experience flying rockets in the level 2. Minimum of 2 flights is desired. The mentor is also the flyer of record for the NASA teams, and they should have a working knowledge of the NASA documents and also the NAR high power safety code. They're responsible. Basically, if you sign up as the mentor, you own the rocket. And as the owner of the rocket, the mentor should be reviewing the design, the build, and basically the mentor has to be satisfied that it is a good rocket to fly because he is taking responsibility. Also, the mentor will handle any of the energetics on the rocket. They will travel with the rocket and the team for liability purposes, and they have to be at the launch week. The ESRA SAC overview. So this is a 6-day event in June, and this is in Las Cruces, New Mexico. One disadvantage of the SAC event compared to SLI is it's hot out there. It's typically around 100 degrees. So if you're volunteering to support SAC, make sure you can handle the high temperatures. They provide a lot of water and drinks and shade, but it's still somewhat brutal out there for the environment. It's a Tripoli sponsored launch, except for liquid fueled. I mentioned earlier that experimental rockets are allowed. That includes hybrids and liquids. So there's several design guides for that competition, what they call for how to build those rockets. It's about a 50-page document, if I remember, and it's pretty thorough. There's also rules for how it's scored and entries. And finally, the Tripoli safety code is in effect for this launch. This goes up to the maximums of both organizations. They allow O motors, again, hybrids, solids, and liquids. And the students are allowed to develop their own solid and hybrid motors. The requirements for this, there's several mentors that can be participating in Spaceport America. They are a separate individual from the flyer of record. They don't have to be affiliated with the school. They have to have experience with level 3 rockets. So obviously level 3 certification. They need to maintain a current certification, either with the NAR or Tripoli. And ESRA recommends that they've flown and recovered at least 5 level 3 rockets, building one from scratch. The mentors are not required to attend the SAC launch, which is different from SLI. They should have working knowledge of the documents I talked about earlier. About the student developed motors, there can be additional mentors who are specialized in these areas. And these mentors should have experience designing and building the motors. They can be a separate individual from the airframe mentor. And they should be familiar with things like the grain geometry, the nozzle characteristics, burn time, how you test rocket motors, manufacturing. So there's a number of things they should be familiar with. Again, this is a specialty area that applies to the student, to the Spaceport America Cup. Again, designing and building the motors. They should know about the various softwares, motor analysis tools, and how to review the motor performance predictions. And they should also be knowledgeable on the safety practices. There have been incidents in the past during motor construction, not necessarily associated with the SAC directly, but there have been issues with motor propellant mixing and assembly in the past. And of course, we all know about test issues, as in catastrophic failures. Okay, the hybrids, somewhat different animal from the solids. And again, it could be a separate mentor. They need to be experienced with handling a liquefied nitrous oxide. Again, we talked about the desert conditions out there. That's particularly difficult for hybrids because hybrids like it somewhere around 73 degrees, give or take. So it's a challenge out there at the Spaceport America Cup. The mentor, again, should have experience regarding the motor hardware, the motor cases, the oxidizer using nitrous is pressurized, so they need to know about pressurized vessels, closures, and nozzles. Again, knowing how to predict the performance and again, the good safety practices. I'm going to switch back to the view just to look to see if there's chat type stuff or questions. Okay, no questions. Boy, I must be covering everything and thoroughly. So going back to chat, and one goal, by the way, of this presentation is, as I mentioned earlier, the SLI basically ends in April. So the schools are very much far along for SLI for getting their rockets and their various meetings like preliminary design reviews, critical design reviews. So this year it's a little bit late to participate in those events. The Spaceport America Cup, they run a little bit later. They're in June. A lot of the teams have mentors and flyers of record. So one of the objectives of this presentation is to get people interested in being a mentor or flyer of record and volunteering for the 24-25 competition. Both competitions can always use experienced mentors, and the Spaceport America Cup definitely can use experienced level 3 folks at the field to support inspections, range safety out on the range. So the flyer of record, again, they should have experience with level 3 rockets so they can recognize design flaws. They need to be EEE members. Depending upon how you work with their team, one of the ideas of all of this is that the volunteering is not supposed to be a financial burden on the volunteers. So the teams should be providing some kind of stipend to help cover the cost of the volunteers. Talk with the team if you are sponsoring a team and see what they can do or want to do as far as sponsoring or supporting their mentor. At a minimum, if you're not a EEE member, try to get them to pay for the EEE membership for a Spaceport America Cup flyer of record. And again, you're going to be performing as a flyer of record a detailed safety review. Think of the flyer of record as a level 3 certification type experience, because essentially the level 3 folks who are performing the certification, they are acting as the flyer of record. They are assuming responsibility for a safe flight of your rocket. Okay. Again, they for SAC, they can be separate from the mentors. That's different from SLI. They don't have to be affiliated with the schools. For example, I am the flyer of record for University of Texas, El Paso, University of Arizona, and University of Utah. They can be a student team member if they have the proper certifications. And they have to travel with the team for the launch. They own the rocket for liability purposes. And again, they should have working knowledge of both the DTAG and the EEE safety code. They're responsible for the safe flight. I participate either via Zoom, or actually I have gone to a couple of the teams to actually look at their rocket in person. And even for SAC, the flyer of record will handle the energetics. Okay, I'm going to switch back briefly before we go into what makes a good mentor. Okay, going to go back to the screen. let me just start off by saying is a mentor doesn't solve problems. These are engineering competitions. The students should be solving their problems. And also, a mentor doesn't know everything about high power rocketry, and should be willing to admit it. For example, I don't have experience with very high altitude flights or with high Mach flights. If I really have a question in that area, I know who to go to, and I'll ask questions of those folks if we're getting into an area where I don't have experience. Also, the mentor is not required to be familiar with all the available motors and electronics. The mentor is also not the best source for event rules interpretation. You need to go to the sponsors. They have their various websites, and go to them for event rules interpretation. And finally, a good mentor does know where the resources are if they don't have the experience. For example, if it's a two-stage rocket, I would probably go to Jim Jarvis. It's one of the first people I would go to for that. There's some other folks on the L3CC, the Level 3 Certification Committee, if it's high-speed flight, that I would go to ask questions about high-speed flight. So your guidance and your involvement, as I said before, you're not going to solve the design and construction issues. You're mentoring students in an engineering competition, and the students are supposed to identify the solutions. As an example, the other night working with my University of Arizona team, they had an issue that they were not making the requirements for velocity off of the launch rail. Their stability was a little bit lower than desired for the DTAG, and they were going a little bit high for altitude than what they wanted to go. So we talked about, how can we fix the problems? So again, I didn't say, well, you need to do this, that, and the other thing. What we talked about was, okay, so ask the question, how can you limit the altitude? Okay, you could add weight, you can add drag. Okay, how can you improve stability? Well, you can add weight to the nose. You can make the fins larger. Okay, how do you improve the speed off the rail? You can make the rocket somewhat lighter. You can go to a different thrust curve for the rocket motor. Again, offering ideas how to solve a problem. And even then, I didn't say these ideas. I kind of asked the student, what are the ways that you can improve the stability of a rocket? So what you're trying to do is trigger the thought process. And those are the paths to success. You can demonstrate construction techniques. You're not going to build the rocket for the students, but you may show your own rockets how you built things. You may actually build a sample fin mounting, whatever, to show how things go together. As far as resources, flying sites are one of the big issues for many groups to go flight test their rocket. Usually mentors are associated with a section, and the sections can offer assistance for flying sites, or you're aware within the organization of other flying sites that could do rocket testing. Participate in the design and the testing. Review it, offer suggestions where improvement might be desired. Look at their analyses, their simulations, construction quality. My finding with college students is they are very good at running analyses and simulations. The problem is, since they don't have experience, they don't have the understanding if the analysis or the simulation is giving them back garbage, because there are issues with, do they have the proper inputs? Are they putting in the proper material types? Are they putting in the proper launch conditions? For example, the SAC launch takes place at about 4,000 feet above sea level, and they need to include that in their calculations. A lot of the programs will default to 59 degrees Fahrenheit for a standard day, where in reality, the SAC launch is typically around 100 degrees Fahrenheit. Another issue with college teams where I find them to be somewhat lacking, they have their logistics, their scheduling, and their checklists. So as far as making sure they get parts at the right time in the right place, their scheduling, there's a lot of thought that if I can order these parts from Amazon today and have them tomorrow, which isn't really the case with a lot of rocket parts. And checklists, since they haven't had a lot of experience building and flying, they're not sure what they need to put on a checklist. Safety is one of the most important things. Again, you're dealing with folks that don't have a lot of rocketry experience. That you need to work with them. Safety in several respects. One is on the range, is how does a rocket range operate? And SLI and SAC differ somewhat from a typical, because of their size, from a typical rocket range. There's a lot of upfront safety, looking at reports and looking at the rockets before they ever go to the field. There are inspections on the field. Once they're on the field, since the students, this may be their second time that they've been to a rocket launch, they don't understand our desires to minimize the number of people around a launch pad, when you could have more people at the launch pad, distances, handling of the rocket, that all systems should be safed. And a mentor will call a hard stop if they're not behaving safely. And you need to be able to explain the reason why you call the hard stop so they can correct it. You can also be the flyer of record. You will perform the hazardous operations that they're not certified for. Again, the energetics. And as I said earlier, the volunteers, these folks are all volunteers. We can't do these events without your help. We have a lot of foreign participation at Spaceport America Cup, and they don't have the resources for flyers of record, for certified people, for people who are knowledgeable in high power rocketry. So they do reach out to the U.S. organizations. They reach out extensively to Tripoli. If they know of folks who are participating in the events, they reach out to folks who are participating in the events. I have had calls or emails from Taiwan and India and Turkey requesting support as flyer of record. So this is an appeal here. Consider being a mentor or flyer of record. It's kind of rewarding. It's very good instruction for yourself. You know, you can see how other countries, how other people do rocketry. You can see some unique solutions to problems. I won't say all the unique solutions are good, but that's still a learning process. We'll talk about in the next session as far as what some of the stuff we've seen as far as during inspection, what we're looking for, and some of the problems that we've seen. But again, this is an appeal for volunteers, for either mentors or flyers of record. The NAR, I know, has a number of folks that volunteer for flyer of record and mentor. Chuck Neff is an example, Chris Pearson, to name a few. I believe Jim Wilkerson is also another one of the folks. So definitely for SLI and for SAC, those same people, Jim Jarvis and company, have all volunteered. So I'm going to reduce this and go on to the question. I'm going to open floor up for questions, and I'll be looking at the chat. So Looking at this here, let's see, I'm going to kill the presentation. Ray, yeah, you're right. They don't have a lot of experience. And Reggie, okay. About requiring rockets to be launched at an angle. Yeah, a couple problems we've seen at Apogee. One is that we keep looking for our use of shear pins. It's not unusual for mains to deploy at Apogee. Gee, you sound like a little bit like yesterday's feature presentation. And the problem with SAC is if we get a main in Apogee, especially 30,000 feet, rockets will drift over onto White Sands proving grounds. And that rocket's unrecoverable. Not to say from 30,000 feet that you've got one heck of a walk anyway. We try to look for that. The deployment velocities, again, they're using electronics, so they should be deploying at lower velocities. Let's see, I'm probably mixing up the two here. So Sam, my suggestion is when you're looking through the paperwork, look at the simulations. Typically they're open rocket, and I've seen a lot of issues with simulations, things like improper thicknesses for bulkheads, usually too thin, improper launch conditions. We have 17-foot rails at Spaceport America Cup. We need to make sure that they're using a 17-foot rail, make sure that they're accounting for the high launch altitude at the Spaceport America. I think it's around 4,000 feet, if I remember correctly. So those are things that you need to look at to make sure they don't deploy at high velocity. Let me know if that answers your question, or if we need to talk about it some more. Contacting the teams. Be proactive. You can work both ways here. If you're associated with a university and you know that they're doing a rocket program, or let's say they show up at a launch, be proactive. Reach out and volunteer to support them. We've had folks at the University of Arizona, folks showed up at the SARA launches here in Tucson. SARA, by the way, is Southern Arizona Rocketry Association. And they originally showed up with basic model rockets. And let's just say there were issues. One of the biggest issues was the use of hot melt building the rockets. But a lack of understanding, they actually showed up with some two-stage rockets, and they wanted to put C65s on both stages. So reach out early. If they're thinking about participating in the rocketry hobby, not just these competitions, offer to be a mentor to the group, not necessarily for a specific project, but to assist them in getting knowledgeable in rocketry. And if their goal is to go into one of the collegiate competitions, then definitely step up on record as their mentor or flyer of record. And we could, yes, as far as getting the word out, we're going to try via some of the NAR forums. I'll try in my articles as the safety chair to try to solicit people. I don't know how many folks we have on this chat today or on this review today that actually are participating in the SLI or SAC. I would be curious if you just come back in the chat if you are a mentor. Would like to know if you've been participating, and if you've got experiences to share with me, that would be great. The other objective I had in this was the slides are designed as standalone. And if you want a copy of the slide, basically, you are welcome to email me. Let me go back. I think I had it on there. Let's see. I killed that one. Let me go to the other one that's up. So you are welcome to email me at my email address. I think people can see it, and I will send you the PowerPoints that I'm using today. So if that's working, just put it in the chat so I can know. Okay, Ray, thank you for participating with SLI. I hope to see you out there. Chris, thank you for your support, by the way, on your egg timer products. Appreciate that. Yes, they are focused on propulsion. And again, that's something that the mentor can try to steer them, because as we all know, most of the problems are on recovery, and even at both launches, recovery is where we have the most failures. Okay, Jeff, Joe Hinton, yes, they do need support. We are looking at that this year for Spaceport America Cup, to what we can provide. Ideally, we're talking about providing tents for all the flyers at Spaceport America Cup. The one issue is trying to find a place that has over a half acre's worth of tents is challenging, especially in Las Cruces, New Mexico. Can folks see the slide with the email if you want copies of this of the actual presentation? Okay, got a young team, and they're coming from TARC. Okay, and I didn't cover it here. The SLI rules are somewhat different for high school teams than they are for the collegiate teams. And again, I just focused on the college teams here. There's some differences on payload and how they participate. But Ray, thank you for working with the high school team. And hopefully you guys will be successful out there. Again, I'm always available via my safety email on the NAR website. If there's questions, I'm always happy to try to field questions via that channel to me. Does anyone else have any other questions? I'm going to just put this on down. And I'm going to stop the sharing. You get to look at my, you get to enjoy my looks. Is there anything else out there? Yes, it is. Chris was saying about students going from TARC to SLI. And then the other thing, just keep in mind that the mentor overall that I was talking about here, what makes a good mentor, that applies fully to TARC also. And again, I would encourage folks to be volunteers for TARC. That's a good way to get folks interested in the collegiate competitions, as Chris and Ray are indicating, and get them involved in the higher aspects of the hobby. Anybody else? I'm going to make a last call for questions or comments. And if not, I'm going to call it good. Again, my email is open if folks want copies of the presentation. And okay, then I'm going to sign off. I would invite you back for the second part of the series here. And that's talking about when we do the safety inspections, what are we looking for? And especially even if you participate in level 3 certifications, some of that information could be applicable. And Joe Hinton, thank you. Yes, they all need help there. There are lots of competitions. I mentioned SAC and SLI. I know that SEDS has some competitions. And also there are some of the clubs that sponsor competitions. And thank you very much, everybody. So I guess I'm going to sign off. And again, feel free to contact me. I'll see you in the next session in about 15 minutes. So long now.